Alright, so in this video we're going to use KCL to solve a circuit. Let's go ahead and draw the circuit. I'm going to go with the current source here. And then I'm going to draw a resistor here. And then I'm going to draw another current source right here. And I want to determine a couple of things. I want to determine what is the current first flowing. We'll call this IX. I want to determine what is IX. Let's make this a 5K resistor, 5 kilo ohms. Let's make this 1 milliamp, and let's make this 4 milliamps. And I want to determine what is my voltage on this node, Vx. Okay, again, let's go over a couple things. First, I know that my nodes in this circuit, there's only two of them. There's this yellow node, right? And there's this ground node, which I'll label in green. Okay. And what do I know? Well, I know that the voltage on the ground node is 0 volts. And so I know that I have 0 volts here. And typically I would say, oh, well, I know my current flowing, so I can just determine Vx very quickly using Ohm's law. However, I don't know Ix, so I need to determine Ix. And so I'm going to go ahead and use KCL to determine Ix. And what I'm going to do is I'm going to write a KCL equation at this node. So I have currents entering. I have 1 milliamp coming in from the left. And I have 4 milliamps coming in from the right. And then I have Ix flowing downward, leaving the node. And so based on the way that I described KCL in the previous example, we know that the sum of all currents, the sum of all the currents into a node is equal to 0. But the second way that I wrote it, let me go ahead and grab that. I wrote this: the sum of all currents into a node is equal to the sum of all the currents out of a node. So let's go ahead and put, let's go ahead and put that in here as well. Again. And so if that's the case, well, I can sum the currents that I have entering the node, which is 1 milliamp plus 4 milliamps, and set them equal to the currents leaving the node. Well, the only current leaving the node is Ix. So quite simply, I can determine that Ix is equal to 5 milliamps. All right? And so now I have, here, let me redraw that 5. That's pretty sloppy. 5 milliamps, okay? And so now I also want to determine Vx. Of course, I know that Ix is 5 milliamps, and so I can very easily, like I normally do, just extract this little portion of the circuit, kind of look at it separately, where I know this is 0 volts, this is Vx, and I have 5 milliamps flowing there, 5K resistor. And so I can say that V, the voltage across my resistor, Vx, minus 0 is equal to 5 milliamps multiplied by 5 kilo ohms. The milli and the K cancel, and I get that Vx is 25 volts. All right, and so that is an example of solving a circuit using KCL. That kind of wraps up Kirchhoff's laws, which are KVL and KCL. We're going to use those all the time. KVL, again, is used for writing an equation for the voltage drops around a loop. KCL is used for writing an equation for the currents into and out of a node. And together, they can be used to solve all kinds of circuits. In the next sort of section of this video, I'm going to start, or in this module, I'm going to start talking about combining resistances in series and parallel, which we haven't. I've really avoided using those words because I wanted to push these other points across first. But we're going to be combining resistors, and it's going to give us another tool in our toolkit for how to solve circuits. And without any further delay, I'm going to go ahead and end this video and move on to that one.